Okay, we'll go ahead and get started. If you want to grab your seats. As you know, we had a superb keynote this morning with Dr. Charles Clancy, and it's just delightful for me to be able to introduce Ms. Kristen Baldwin as our afternoon keynote speaker. Many of you in this room have interacted with Ms. Baldwin. As you know, she was our executive sponsor for the SERC for the first 10 years. And so she probably knows us better than just about anybody within the Pentagon. In her continued roles of leadership within the department, Kristen now serves as the Deputy Assistant Secretary in the U.S. Air Force for all science and technology. So in that regard, she essentially provides guidance to the Air Force's $2.6 billion portfolio of research, engineering, and science at laboratories and warfare centers across 40 different sites globally. And so she has now got a much bigger, broader purview, but at heart, she is a systems engineer and a software engineer. That's how we know Kristen. And probably the most important thing I have to tell you all about Kristen is that she's a Virginia Tech alum. So it's like some of us in this room, she's a Hokie. She can do no wrong in our eyes. So Kristen, over to you.
Great, thank you so much. It's wonderful to be back here with the SERC. I was thrilled to be offered the opportunity to be your luncheon keynote or afternoon keynote. And I look forward to telling you a little bit about what I've been up to. It's been about 2.5 years since I moved from the Undersecretary for Research and Engineering in OSD. Some of you are here from R&E, and to the Secretary of the Air Force organization. And Dinesh shared a little bit about my portfolio. I wanted to share a little bit about what we're challenged to do, because as Dinesh mentioned, my passion, my research, the capability that I want to bring hasn't changed. It's from R&E across the DoD to basically the research and engineering enterprise across the Department of the Air Force. The other great thing is we have two services, the Air Force and the Space Force, and so I've had a great opportunity to create and help support the creation of a whole new space force and underpin that with the scientific research engineering workforce capabilities. And so our challenges remain, and I think our need from the SERC enterprise remain very consistent with the type of work that you're already doing. And so as I speak, I think you'll notice that, and I look forward to continuing to try to figure out how we can grow the relationship with the Department of the Air Force. Let me do this here. So I've got I'm gonna do. Well, you're going to have to help me. It's back. Good. Awesome. So, if you take a look across the Department of the Air Force, we focus a lot of what our job is, and really we're challenged to make sure that the programs, the investments, the talents are focused on what our Department of the Air Force DAF strategic priorities are. As some of you may know, we have a new secretary, Honorable Frank Kendall. He's a longtime veteran of the Department of Defense. He was our Undersecretary for Acquisition Technology and Logistics for many years, and we're very fortunate to have him come back to serve in the Department of the Air Force, but really to serve our nation. And so he is a driving force and you'll hear this theme from me today as I speak to you about we need to make progress towards accelerating delivery of operational capabilities, right? Our peer competitors are particularly China, moving at a very, very fast pace, delivering, watching what we've been doing for years, benefiting from the research and development that we invested in, and capitalizing on all of that to deliver new capabilities. And so what Mr. Kendall has done, as you'll see across the bottom of my very first slide here, is a set of 7 operational imperatives. These have emerged from study of operational analysis, competition among peer competitors, future scenarios, and now they help drive our research and investment activity, like I mentioned. So I won't go through each one of them, but you'll see that they span the very first one on the left, resilient space order of battle, building together this airspace and cyber network, and figuring out how do we leverage that to bring to bear the resiliency and communication across our air, land, cyber mission, our airspace and cyber missions, all the way to the other side, and going through families of systems, and future aircraft, future family of systems capabilities, dominating air, dominating long-range strike capabilities, to being able to plan, respond, and be resilient in an operational theater as we transition through all the elements of transitioning to trying to deter, but eventually going into a wartime posture. So these operational imperatives are big drivers. And then each of the services, the Air Force and the Space Force, has future operational capabilities, development needs that they're determining. And what we want to do is we want to build and develop and transition technology and capabilities to meet these needs. SAF AQR is the acronym title for my organization. That's just the acquisition organization for research and engineering. And so I have 4 kind of priorities that I use to drive our initiatives. And this is where I think you'll see a lot of similarities in shared interests here. In no order at all, but just sort of starting at the top left, what we want to do is be able to drive our science and technology prototyping, experimentation activities towards tech transition opportunities, so we can accelerate delivery of warfighting capabilities. That's anything that we can do, and I'll talk a lot more about that as I walk through these slides. Moving around clockwise, strengthening the cyber resiliency of those capabilities that we do deliver. This is a wonderful part of your research agenda here at the SERC, and continues to be critical. And I would say that we also are, one of the other activities that we're doing, which I took from my former position in OSD research and engineering, is to think not only about resiliency of our engineered capabilities, but think about how do we apply appropriate protections in our technology development activities. Moving around, workforce, our talent, and the tools that we give that talent and that workforce, and to equip them is really critical. We are at a competition for talent, just like we're at a competition for national security and national and economic security. So we want to build the best. We want to grow a diverse, talented workforce that can have the skills that we need currently, as well as for our future capabilities that we're transitioning from research. So many of you are very familiar with our national defense strategy. Our national security strategy identifies a list of critical technology modernization priorities. As we transition, as we mature those technologies, and we think about how they can apply to defense activities, defense capabilities, we have to think about how are we going to build build with those, manufacture with those, engineer those capabilities, whether it be advanced hypersonics, microelectronics, artificial intelligence, directed energy types of capabilities, and on and on and on. And so we continue to have a very important need to evaluate the competency needs that and gaps that we have right now, and then how do we think about growing those gaps? So I'm really interested in the SERC's continued involvement in this research activity, so that we can work together. And then finally, true at heart, like Dr. Verma said, a systems engineer. How can we continue in the Department of the Air Force to bring that engineering rigor and advance our engineering state of practice to meet the challenges that we face, whether it be from being able to think about engineering at the enterprise level, engineering across missions, architecting and networking, and transforming our engineering state of practice through application of digital and data technologies. So as we think about that first slide that I showed you, what are the Department of the Air Force priorities? And then, how can we then transform our activities, our functions, whether they be research and engineering and workforce, towards achieving that investment change? We understand that this is going to change our business practices. This is going to need to change our investments. And so what the Air Force has been doing over the past year is we stood up operation teams co-chaired by an acquisition lead and an operational lead, a requirements lead, an operational lead, to partner together and really deeply understand the operational imperative. Do deep strategic analysis, systems analysis of that challenge area, understand the mission threads, understand our current capabilities, understand technology opportunities. And so we've been applying these activities in each of these 7 areas, and as a result, we've identified investments that we need to make and investments that we need to probably transition from. And we've identified that the value that we gain by applying that analytical and engineering tools and infrastructure to be able to help make sure that we continue to think about these new capabilities. And I'm going to talk a little bit about our engineering and technical approaches to trying to apply digital modeling, simulation, and analysis underneath these teams to help advise the changes in investment and in to meet these DAF priorities. And they become vectors as well. So we've identified sort of, what is it that we need to do, what's in the realm of the possible. And now what we're trying to do is shape our investments, whether they be science and technology investments, our basic research investments, prototyping, experimentation, and our program investments. What are our transition opportunities? What are existing program opportunities that we can modify and adapt over time? And so that's really kind of what I spend, that's really the focus of the Department of the Air Force workforce. That's what we are heads down doing. And you'll see it all roll out as we deliver the budget to the president in January, and then as the president delivers the budget to the Congress, you'll see it all roll out, and it's all based on this strategy to outcome, priority, and analysis. So the bottom line on that last chart is, how can we do all that in faster timeline, right? Because we know we can't just be satisfied with the long-term traditional acquisition approaches. We want to accelerate. We want to improve the speed and effectiveness of our activities, of our processes, and we want to accelerate the delivery of capability. So our Chief of Staff of the Air Force says we must accelerate change or lose. So it's driven into our ethos of the Department of the Air Force today. Now, we did a study at the direction of Mr. Kendall about last year this time. He said, hey, we need to take a look at our tech transition pipelines and mechanisms, and we need to figure out how we can improve those for greater efficiency and speed. And so what this just gives you a sense of, and many of you, the font is small, but I'll highlight a couple things. You know, you've got sort of at the bottom, you've got sort of the life cycle of budget activities, from our basic research to our operations and maintenance activities. This is the way the department invests in these budget activities. But just think of it like a total life cycle. And in the middle, you can see sort of a red line that says the valley of death. And we know very often in our work, like what we seek to really do. And one of the biggest challenges when you go from research to capabilities is you really kind of sometimes you get hung up in this valley of death, and it becomes really hard to cross and actually become a program of record and actually go into major procurement and delivery and fielding of capability. And so we looked at all the different types of, there's about 14 or so different types of tech transition mechanisms, and what they are isn't really important, but you know, kind of how they group and what are the ways in which they try to do the work that they're trying to do, whether they be advanced technology demonstrations, or whether they be rapid capabilities or prototyping, joint capability technology demonstrations, rapid prototyping activities, SBIR and SIR, small business innovative research activities. You may have heard of Air Force SAF works, Space Works. We have different, each of the services and many of the agencies have opportunities that are reaching out to small businesses and trying to bring new talent and tools and innovation into the department. And so they're all listed here. And so what we did was we took a look at what all these opportunities and activities and mechanisms are, and we took a look at what is it that's so hard about tech transition, and where do we get so hung up on tech transition. And so we did a search across literature search, and we found over 60 studies of tech transition. It's a well-studied topic, as many of you know. And when we pulled out some common themes from about 38 of those 60 studies or so were very relevant to the challenges that the Department of the Air Force is really interested in, right? Stable, consistent, strategic focus areas and priorities. The ability to understand and convey the value of the new technology to the user that's going to employ it. Countering a risk-averse culture. Having funding to get you across the valley of death. It takes 2 years to get something in the appropriation and start a new program. What do you do during that 2 years? How do you keep the momentum going, and how do you accelerate that capability? You see these themes across all of the studies that we did on the left-hand side. And so we kind of assimilated all these findings through over a few months, and we briefed the Secretary of the Air Force last spring on some tech transition improvement areas. And that's really what I wanted to highlight for you on this slide. And I've bolded some of the key findings. Number one, we do need to have funding flexibility and resources that allow us to react in a quicker time within that 2-year planning and programming and budgeting cycle that we go through. And so the Air Force is really actually quite lucky. We actually have programs. We have a tech transition program, and we have a requirements analysis and maturation program. Not all the services have this, and so we're focusing very hard on engaging with OSD, engaging with the Congress, and engaging with our leadership to make best, most strategic use of those critical, precious resources that we have programmed in the tech transition program element. So that's a big focus of what we're doing. The second one, revitalizing capability development planning. That is the activity that kind of falls between taking an understanding of a technology opportunity, maturing it, doing concept analysis, concept refinement, early systems engineering, early acquisition planning, so that we can de-risk activities and have a more streamlined ability to on-ramp to a program of record. Development planning is something that we've been doing in the Department of Defense, particularly in the Air Force, since the 1960s. But but we kind of go in waves of how focused we are and how much we rely on that underpinning analysis to bridge the valley of death. And so what we're doing in the Air Force right now is revitalizing or refocusing on that critical activity. And I'll talk a little bit more about what we're doing there. Improving our communication and tools with our non-traditional partners. We need to be able to outreach across the department, across the nation, capture as many of the ideas, the talent, the tools and the capabilities that we can from as broad a spectrum. And of course, that means commercial industry. Many of those technology modernization priorities that I mentioned are commercial-led technologies, as you well know. So how do we break down barriers and enable better communication about what we need with that commercial industry partner, and how do we use non-traditional kind of means in order to contract with them to make it easier for us to do business together. The fourth one, bold, is implementing our digital modeling, simulation, and analysis capability. We need to continue to grow that. We have to have ability to simulate, vignettes. We have to have ability to simulate more dynamic scenarios, not just very, very traditional focused operational plans and activities. It's a very dynamic, changing environment when you think about the pace of technology. And so we need to have an ability to really bring to bear that digital modeling and analysis in a much broader way to underpin much more of the decisions. Agile, I'm going to talk a little bit. The fifth one is the enabling capability that we get through digital transformation. And in the Department of the Air Force, digital transformation means that we're doing digital engineering, digital model-based engineering. We're doing, we're applying and implementing an open architecture and open standards activities, and then we're applying agile practices, agile software practices. And I'll talk a little bit more about that. And then finally, our workforce. You have to focus the priorities. You have to have everybody understand the priorities through good communication. You have to have good workforce and skills that are built up and processes that are going to enable those priorities to be realized. So capability development planning, just a quick slide on that. What we've done is we established one of the key things, capability development planning 101, is that you bring together the requirements, the acquisition, and the resourcing stakeholders. Because to get across that valley of death, you can have a great idea in the acquisition team, but it'll never get there if the requirements guy doesn't want it, right? Or hasn't written you a requirement or figured out the concept about how to use it. And you'll never get there if you don't have the resourcing, right? And so these critical, we used to call them a couple of years ago, like kind of the three-legged stool, big acquisition. What does it take to really do good acquisition? It's that three-legged stool, requirements, acquisition, and programming. And so we've put together a capability development forum that brings together the leadership of those across those three major department of the Air Force process. And we're focusing our attention on the critical priorities, the strategic priorities. The other thing we're doing is we're trying to underpin everything that we're seeking to transition across that valley of death through those multiple pipelines, underpin that with some rigor that takes a look at the maturity or the readiness from different lenses. Am I ready from a technology perspective, a technical perspective? Is it feasible to do what I think I want to do? Am I ready from a mission perspective? Do I understand how that technology can benefit a particular Department of the Air Force need, capability in a mission sense? Do I have the funding? Do I understand what funding I need? Which is really hard when you have an initial technology, right? We don't have detailed cost analyses for and modeling for many of these new technologies to be used in new ways. We don't always have that. That's hard. So you have to really pay attention to that. And then finally, do you have an organization? How are we going to organize, train, field, and equip this capability? Who is the lead program office for this new capability that we may not have maybe it's not an aircraft, so we don't have a PEO, a program executive office. So you need to take a look at all of these different attributes in order to understand where you are in terms of readiness to transition that valley of death. And what we found is, these activities, they get tripped up a lot in the valley because we know some, but we don't know all of them. And we know, and we know different parts of each of these. And so we're trying to put some rigor behind these decisions, behind these investments, and looking at it through these lenses. So I'll show you a little bit about what, maybe an example is good. So many of you are aware that we have a concept in the Air Force that we want to equip our fifth gen, our sixth gen aircraft with the opportunity to have maybe what we call maybe a autonomous platform. How can we network together unmanned capabilities, unmanned aerial vehicles so that they can network and operate together as a family of system with our manned aircraft? And can you then have a better ability to distribute some of the functions that you're trying to bring to bear as a total capability to achieve a mission capability? And so we initiated a Vanguard program called Skyborg, which was taking a look at what could we do to network together and build autonomous capability across unmanned platforms, and how could then they communicate and work together with manned platforms. And so we started a science and technology program, but at the same time we were thinking about this in a holistic fashion. How can we actually bridge that valley for this concept? So we invested S&T dollars to work out an autonomous core system. Can we replicate autonomy? Can we understand the autonomy behaviors on different types of platforms? And can we load that system on multiple platforms and have it operate in different mission capabilities? And how does that all work together? So we needed some S&T investments and projects to do that. At the same time, we needed to understand how are we going to actually employ these systems? What's the concept for employing a family of autonomous systems? And so we also invested in some experimentation and prototyping activities that allowed us to really understand the concepts underpinning these, which inform the technology and inform the requirements, right? So we did that at the same time. At the same time, we identified the program executive office, the program manager, at the PEO, and we created a strong partnership with them because they're already engineering and fielding and maintaining and sustaining a long historical pipeline of manned platforms, and they're starting to look at these unmanned platforms. And so they are going to be the eventual owner of this capability. So you got to have them in on the front end. And we went out and worked with our operational field commands. When I say Headquarters Air Force Major Command, it's a big acronym there. That's our capability development. That's our requirements team. That's who's writing the requirements. And so we had this Vanguard program for this Skyborg autonomous capability. This is how we structured the program. And because we did it like this, we were able, that program, that Skyborg Vanguard program, is now transitioning to the PEO. And it's one of the things that we're working really hard on. And RFPs have gone out to broad industry to bid against real requirements to help do the concept refinement and maybe result in a future program. So that's a good example just to kind of pull it all together. Now, this is a terrible eye chart, but the point of this is we're trying to work on, I mentioned, how do you take those four lenses, TMRO, and then how do you try to put some rigor into the way that you're going to assess these different technology concepts to, kind of see, what's my readiness in terms of these different lenses. So, you think about discovery at the top, and then you kind of think about, okay, what is the art of the possible? And then how can I incubate those ideas and think about them a little bit deeper? And then how can I accelerate and kind of get into the more delivery phase, right? So that's all you need to take away from this eye chart is 4 columns, right? TMRO, 4 lenses, and then the rows of just kind of thinking about the readiness, or maturity, right? As you're trying to deliver these. So an example in maybe a more readable fashion. Taken two of those lenses, the first two, technology and mission. So we take a look at, and so I'm showing you this because the SERC is a research activity, and you might have some ideas on helping us to flesh this out and make it more rigorous and think harder about this. So I just wanted to share it with you. Very, very nascent, right? But we're trying to apply this methodology and we're trying to grow it as we apply it, right? So from a technology perspective, right, is it feasible? Does it violate the laws of physics? Have we thought about integration challenges? When we pull all this together, have we underpinned it with some kind of model-based and standards and approaches? How is it all going to fit together? How do we get that data? How do we address that uncertainty? So we can ask all these questions, but we got to go out, engage with the community and find out ways to deliver the data to help answer this question, whether it be from experts that know about this, or whether we can whether we can model activities and get knowledge through modeling and simulation, or whether we can do demonstrations, prototypes. And so for each of these lenses, we're trying to apply some kind of consistency rigor. So technology, mission, how does it fit within the existing or future missions and concepts that our services and our warfighters are applying? What are their undesirable third order effects? What are the vulnerabilities, countermeasures? And then how do we go about getting that information in detail? The other two lenses, resourcing, do we have the resources? I mentioned before, cost estimating. We don't necessarily have, detailed cost estimating activities that go on during technology development. So we got to start thinking about that. So we need to think about costing in the way that we think about, systems engineering. Skills, those are resources as well. And then organization, as I mentioned, do we have the right stakeholders? Do we understand how are we going to produce this capability? How do we sustain it? And who's going to own it? And how is it maintained? So that was a little bit about capability development planning. I wanted to also just talk a little bit about Department of the Air Force digital engineering. I mentioned before, we kind of have this three-pronged, kind of maybe a trinity type of approach where you're thinking about digital model-based engineering, you're thinking about open architecture and agile processes. We see digital transformation as an entire digital ecosystem. We don't see it just for our programs. We don't see it just in acquisition, but it really is transformative in the way that we want to operate our business practices and deliver capabilities. We see it as an opportunity for unprecedented government and industry collaboration and academic collaboration as well. We're proving that. We already have that going on in many of our digital transformation examples with our programs. We see it as a holistic approach across the life cycle, and I'll share that with you on the next slide. And as many of you know who helped write the digital strategy for the Department of Defense, the key thing is that knowledge is not disposed, it continues to grow, whether it be your system model, your digital thread, or your authoritative source of truth. So from a life cycle perspective, I don't want to spend too much time on this, kind of beat the horse, so to speak. But we see what we're trying to do is apply digital model-based tools and architectures from the left-hand side of the chart, where we're thinking about how can I, as I was talking about before, bringing together those technologies and thinking about transitioning into programs. How can we understand the trade space? How can we bring to bear digital model-based engineering and tools to be able to better understand, capture, and evaluate trade space and operational analysis, and all the things that I described before? The second kind of thing, how do we help derive our requirements, our system specs? How do we make more available reference architectures that can be used for system types or domain types? Of course, during system development and our engineering and technical reviews, and then throughout the system lifecycle, we're doing some fantastic things in our sustainment activities. We have underpinned our digital strategy with cloud-based enterprise environments. These continue to grow. It's been a key challenge for us to figure out how to scale these in a way that can also engage with other existing environments that industry may have, in existing environments that some of our program offices may have, and environments that our partners across the services and DoD have. So this is, scaling, this cloud-based, shared, integrated digital environment is a challenge that we continue to face, but it's part of our strategy. So what have we done? We started a digital campaign. We had over 900 people from across the acquisition community of all types, whether they were engineers, scientists, program activities, logisticians, program managers is what I meant to say. And we've created some initial guidebooks. We've initiated major lines of effort to kind of tackle key challenges like data access and how do you write a contract data item description or a seed role for a contract that asks for a digital artifact instead of a paper document, right? And we established a digital building code that set some expectations for our acquisition program managers, so that we can try to reinforce it from top down. We utilized much of what had been done by Cozy and many of you in this whole community to think about digital maturity metrics, and we applied those. We leveraged heavily those, and we sought to apply those to our program managers so that they could think about their digital journey. How do I apply? How do I transform what I'm doing today? And so we've made heavy use of those, and we did stand up a digital transformation office as a focal point. But we're just beginning the journey. I mentioned this digital building code. What we said was all new programs, you are going to be born digital, so to speak, right? Existing programs, which we have a lot of, legacy programs, we want you to do an analysis to see where you can get the best return on investment for applying digital activities in your program, whether it be your next upgrade or whether it be a particular aspect of the sustainment activity that you're doing, or what makes most sense. And so our PEOs, our program executives, they're all doing this. They're all kind of trying to figure that out. And we're seeking to update this building code guidance each year because we are in this activity where we want to transform, but we're trying to build it as we go. So this will be, I say here, published in May, a year ago May, and we're getting out the next version here. It's in final coordination with our new service acquisition executives, both of them. I talked a little bit about open architectures. You are well familiar with this. I just wanted to share a little bit about how we're thinking about this and trying to make this real, so to speak, in the Air Force. And so we have a open architecture management office and a program that's trying to really mature and, I guess, I don't know if curate is the right word, but continue to mature and grow different types of architectures that we and we made some mandatory: open mission systems, universal armament interface, and so we have an activity that's seeking to grow and mature architectures. We're creating repositories, and we're trying to find ways to share those across the DoD and with industry. So that's that's the intent. And we're building out reference architectures for critical system types. So an example of one is our avionics reference architecture. And I use it as an example because it kind of shows you how we can think about, a reference architecture will bring together sub-architectures that describe key components of a particular platforms, like an avionics platform. So we think about what are the standards that we want to proliferate repetitively for software, for mission functions. What do we have as for electronic warfare subsystem capabilities, as subsystem components or capabilities? Our sensors, payloads that we're putting on our avionics platforms, our aircraft. Communications. And so this what we're building out is a reference architecture for an avionics platform that pulls together and integrates all of these subsystem architectures. And the more that we can apply these different subsystems and major avionics references architecture, kind of descriptions and guides, the more we hope our industry partners, our platform builders, will be able to better integrate and upgrade, apply new tech transition opportunities, because maybe we're more modular, and we'll be better able to integrate these systems when they operate like a family of systems, like I described for our future avionics capability. So this gives you a little bit of a sense of our open and government reference architecture approach. Again, this is something that's very much in work and has lots of challenges and opportunities for assistance from entities, activities like the SERC. Space, I haven't mentioned that much about space, but our Space Systems Command is very interested in building out. This is another, I talked about an aircraft platform, but when you think about the system of systems to achieving a space capability, we're building out ground systems architectures or reference architectures and standards, and their system of systems as they create with satellite vehicles and payloads that may be that are associated with those satellite vehicles and launch vehicles. So there's a lot of activity here that is seeking to grow, and is really opportunity for collaboration. And so just pulling it all together, digital transformation, I just wanted to show that we have a series of examples. What we basically did was we said, go out, all our programs, like I mentioned, new programs born joint, all existing programs, get on a digital maturity model activity and figure out how you can implement this. And so what's happened is we've got a terrific set of instances, examples across the life cycle. So I mentioned Skyborg. We applied digital model-based engineering into our Skyborg S&T program, and the way that we captured the prototyping activities and modeling activities for that autonomy core system that we developed. And that's on the left-hand side. So it's a good example of how you can apply these tools in the very early phases of technology development. As you move through, our ground-based defense system, our Minuteman Minuteman replacement, GBSD, now called Sentinel, they applied digital model-based engineering activities and open standards for their requirements generation phases and their system specifications. Moving along, our next generation air dominance, that's this family of systems, manned and unmanned platforms. They applied very heavily open system architectures and requirements. B-52, this is an example of a terrific legacy platform, right? But they're re-engineering their new engine capability. We issued RFPs for a digital model, not a paper model. And we were able, because we did that, we were able to accelerate our time to PDR, and we were able to go right into kind of a 3D printing of a prototype capability. And it's so the program has really benefited from that. And then our A10 legacy platform, because we digitized the drawings, we saved 2,000 hours of maintenance, which has made that aircraft increased huge operational availability for that aircraft. So real examples, full life cycle, real benefits, different types of benefits to different types of programs. And so we want to continue to grow this. A little bit on workforce, just like the Secretary last year initiated this tech transition activity, initiative, how can we improve tech transition? He recognizes fully and completely that we cannot win unless we have the organic talent. And partnership that we need. So we embarked on a major effort to determine what do we need to do to foster the organic excellence that we need. And so there's a series of recommendations that we're trying to move out and implement, which cross many of the areas that the SERC has invested in human capital for engineering and technology over the years. And I really would like to continue to capitalize on things that you're learning, ideas. Couple, just kind of a shout out to one of the things that we're going to try to expand on is our legacy program for STEM development. So we do STEM. Our nation loves, we have just embraced STEM as a nation. We all have STEM projects, K through 12, K through 16, whatever it is, right? What legacy does is it's a concept where how would you do STEM differently if you did it like an NBA recruiter or like a softball sports team recruiter, So your daughter's on the sports on the softball team, and the college is looking at her when she is in junior high, right? How can we do that with STEM? How can we keep the K through 12 STEM project partner that we're engaging with in these STEM programs? How can we keep them, keep track of them, keep them engaged as they become maybe a junior apprentice, maybe as they do an internship, and then maybe as they become a Department of the Air Force Smart Scholar, where we're actually paying for some of their education in return for they want to stay with us. So legacy is a deliberate approach to create be a recruiter for our future organic technical workforce. So we're going to overhaul our STEM strategy for the department, make it more targeted, make it more objective and measurable, and hopefully be able to, achieve the talent growth that we need to make sure that we can win against our peer competitors. And so I've talked a lot today, obviously, and I wanted to have a few minutes for any questions that you might have as well. But some of the challenges that I've talked through, and some of the activities that we're undertaking, that you may have have customers in the SERC and in the research that you're doing in these areas. We know we face. I mentioned some of the first one is how do we integrate these digital environments, and especially when we have different levels of classification. And so we're really trying to break down some of those classification barriers. But it is obviously a real challenge. Intellectual property rights, data rights, access, exchange, ownership. This is not a new issue. Data model curation, verification, validation. I won't read all these. Cyber resiliency of our systems. How do we think about digital cyber assessments, right? How can we automate? How can we bring to bear some opportunities there? And then finally, the workforce STEM overhaul. So. I think I would leave with some of those challenges and a hope for a continued partnership with the Department of the Air Force and the SERC. Passionate about the SERC, so proud of what you all have achieved and what you continue to be. And I'd be happy to take any questions. Or comments. You don't have to ask a question.
Do you have a slide or have thought about, when you had the technology, mission, resource organization on the one, and then you had the uncertainty, you had those matrices, that you have something like a flow of information and who gets what handoff. So, you're going from the research and then it gets handed off and then somehow it gets lost. And so essentially continuity of information across not only the Air Force, but actually the whole Department of Defense and really the enterprise itself, so that you can just visualize who knows what, where, when, and how. And it just makes it a lot easier instead of getting just, flood of sort of dots.
Yeah, so we are starting to try to build out a information type of repository. So all those assessments, you're right, as I was describing, we want to understand, this data, this information. We are in fact working with we're working with our requirements community, frankly, our capability development community. They are building out a information repository that is trying right now to trace this, to keep track and curate this information so that it can be referenced and utilized. So we're growing that right now. Challenges are sometimes the information comes in a tech report. Sometimes the information comes in, maybe a PowerPoint slide, but sometimes the information comes in a model, a simulation result, right? Or a data, a data artifact. And so those are some of the challenges that we're facing. The other part of your question is how do we not just do it for Air Force and Space Force, but right, our other partners. So we're starting to have some, we've engaged in some really, really great discussions with the R&E organization. And I don't know, I saw Dr. Judith Dahman on the roster here. You may be talking about mission engineering. What R&E is trying to do for the kind of the joint warfight is to think about digital model-based approaches to how these capabilities are able to have an impact. What we want to do so we're trying to partner with R&E, and if they're modeling a mission, we want to make sure that we're modeling the same mission. You know what I mean? Or how can we leverage that? And then so my best answer right now for your question is that can hopefully allow for better, easier transition of information, and sharing of information. But we're nascent in trying to capture those data and information that are helping us look through those lenses.
Hey, hi, some comments. Sandy Neville, Department of Navy, NavAir. So I've listened to you for years, and I always appreciate your enthusiasm and leadership in this space. And I think a lot of other people in the room would echo that. I just wanted to let you know, collaboratively, we've attended a few DE conferences recently at NASA and the NDIA,
Yes.
And we're working closely with your Digital Transformation Office, NavAir, and we're partnering with people from the Army and things like that. So we're going to try to extend and collaborate and share and
Good.
And also working, OSD has the digital engineering body of knowledge.
Yes.
I'm one of the leaders of the Naval Digital Engineering Body of Knowledge. You have the digital guide. We're trying to figure out that strategy, how we can share stuff. And, maybe it's different information, but just kind of like mindful of that stuff. So just a comment there. And then the last thing was I love the STEM and the legacy, what you're trying to do there. And the one thing that I think that we talked about it at length at lunch and on breaks is we get people in. You mentioned internships. So just the idea of when you bring an intern in for everybody, just engage them right out of the gate. Because I think that's where we kind of
because we bring them in and we lose them. We put them in a corner and we say, read this manual.
Right, exactly. That's
and then we forget about them.
Yeah.
There's horror stories. You're absolutely right.
Yeah. So I love hearing you talk about it. I'm sure you can help us.
Yes. So we recognize that. We're really worried about that. And actually, one of the things that I said to Mr. Kendall, I was like, if nothing else, these digital engineering tools bring opportunity to get our engineers working rather than just reading or overseeing or watching engineering happen, right? Or watching acquisition. They're actually able to do it. So in some of these small pockets, at Hill Air Force Base, they have sort of a digital kind of camp, and they've got, so we're starting to pop those up and it's kind of bringing to bear the tools, the environments, and our young engineers to teach us how to use these things too, right? Because so you're absolutely right. We got to think about how to grow and mature. And that I think is one of the cool SERC, kind of looking at Nicole, right? Or, just, the human capital challenge, right? How do you continue to grow throughout the career? It's different than it used to be, right? And think about ways to gain experiences, not from just a book classroom, but from an opportunity, a fellowship, an experience, and how do we grow our engineers in that way, in a timely way? Thank you. Yes, it's so important.
Kristen, this is a question that I asked the industry panel last night, and the question was, in your TMRO chart, technology readiness and organizational readiness compete for resources. And the industry folks kind of said, well, we don't even think about that because we just know it. But it seems like in DoD program offices, the balance always leans towards technology. How are you creating that balance in your strategy?
You mean the technology resourcing versus the organizations? Yeah.
Organizational change, if you want to call that, like digital engineering.
Right. So we are, I think you saw on the vision, we see it as needing to transform practices, our organizational practices. So one barrier is, right, you can do all that digital engineering in the engineering teams and you'll still be making decisions the same old way. Is that kind of part of what you're saying? We're hopeful that with those examples being brought to bear about by all those different programs across the life cycle, that those examples will be able, what we need to now do is not just have those individual unique examples, but we need to learn and measure from the outcomes from those examples to demonstrate to the organizational leaders that they've actually, that there has been a benefit. So to incentivize them to change and do things differently. That's my best example. Is that I think where we need to get better at now is measuring, did I actually accelerate? Did my application of those digital tools actually accelerate my ability to deliver, right? Because the boss, the secretary, wants us to accelerate capability delivery, right? If we can show that the application of these tools by the technical staff has achieved that, I'm hopeful we can get the organizational transformation to occur. But yeah, I hope that answers your question, Tom.
Good, thank you.
All
We're
right.
just about out of time. We have to run to our next session.
Yep. Thanks all very much. Pleasure to be here again. Take care.